Energy solutions in the most sustainable neighborhood in Bergen. That sounds big and hairy, and I think you will see that we spend a lot of time trying to find the optimal energy solutions for this new neighborhood that we are building, hopefully. First, my name is Louise Sondrup, and I'm head of innovation in Eviny. So everything that's not anything yet is my responsibility. And I've also been very lucky to be project manager from Eviny for this project. And then Anna is also with me. Anna works in Volde, our power company, and she earlier worked in Eviny Thermo, and she is a lot more qualified actually to talk about energy solutions than I am. So if there are any technical questions afterwards, Anna will hopefully help me answer them. So the project, most of you who live in Bergen have probably seen the big transformer station by Ulriken. And the fact is that that transformer is undersized to cover the demand of the future. And that was a realization about 4 or 5 years ago. And then BKK Nets, our colleagues there, they started to think, how can we do something spectacular when we need to upgrade the transformer? And they realized that the view from the area is very spectacular. And even though we love transformers in Eviny, we think that that view can be used for something better than an outdoor transformer. So we are thinking that we want to build an entire new neighborhood in the area, and instead building a compact transformer in the outskirts of the area. So the compact transformer will cover the future needs and leave space for a lot of new residential areas. And our ambitions for the project is that to contribute to the environmentally goals in Bergen, to build sustainable. And then naturally, we also need to cover the extra costs to build a compact transformer, because it's quite a lot more expensive than it is to upgrade the outdoor transformer. And then we set some pretty big goals regarding sustainability. We are thinking of what kind of material we will use, and also energy, like I'm going into detail with today. The first goal is that we want to utilize the excess heat from the transformer and maximize solar power production. And then we also saw that there was a good fit to also use district heating, and maybe turn the whole area into a smart hub using batteries. We don't know yet. And then it's also important, when you talk sustainability, to look at how people move themselves and also to make people stay there. So that's why we look at shared solutions, both for mobility, but also a co-working space, greenhouse, etc. So that is a very, very brief overview of the project. Like you said, Kristen, there was just an article in the newspaper about the project, and this is what we envision at this point. About 130 homes organized in tunes. I'm not sure what the English word is, in around the squares, like you can see on the drawing. And we are gonna rehabilitate the old transformer building. So we're not gonna tear it, but we're gonna rehabilitate it and build apartments there. And then we want to build a kindergarten in the corner, which has direct access to Mount Ulriken, and new compact transformer, like I said, in the western corner. So that will be here underneath the residential homes. And like you know, today the transformer is a very closed area, and one important point is also to make the area accessible for everyone, not just the people living there, but people who are walking and moving towards Ulriken or the other way. So we have thought a lot about how people transport themselves to make the area accessible. So that was a very brief overview. We've gotten support from Innova to conduct analysis of the optimal energy system on Montana, and we've spent basically the last year conducting these analysis. Anna and I has together with Sweco, very competent energy consultants from Sweco, conducted the analysis. And the focus on the energy analysis was obviously first you need to understand the energy needs of the area, both electric and thermo needs. And then was a big and important focus for us to find out how we best utilize the excess heat from the transformer, because you all probably know that a transformer generates a lot of heat, which is normally just dumped into the air, and we thought that was a big problem, and that we need to make use of that heat. So we spend a lot of time gathering information from similar projects. There are some projects around the world. I'm going to go very briefly into it later. And analyzing different options based on economy and sustainability, and then choosing the preferred energy system for the area. And also looking at the electric system and solar power production, because we see that there are a lot of regulatory challenges in regards to this. And that the area will need some smartness, which is not a possibility to buy today, but we think that technologically everything will develop a lot the next 3-4 years until the homes are built. So we haven't made concrete decisions for how we should control, but more set goals on what needs to be controlled. And then we looked at the business model and different roles and interfaces. So I'm going to spend most time on the how to utilize the excess heat, but first, briefly, I will just give you some understanding of the sizes in the area. So this is what has been calculated to be the needs. This is the both ventilation and heating, and also hot water in the tap, so I would say. So in total about 720,000 kilowatt hours per year. And then for the electric heat or the electric use, the amount we think the area will need is about 466,000 kilowatt hours with a max effect on 86 kilowatt. And that's a combination of a bit power charging to electric vehicles and other use. Yeah, so that was very brief. And in regards to solar, I'm not going to go into detail, but what we've done in order to maximize the solar production is two things. We've organized the homes in order to maximize the production and not necessarily maximize it in total, but as much production as possible in the afternoon. And moreover, we have changed the ceiling angle of all the houses, so it's possible to have more solar production on the roof than if we've had a regular ceiling. And here you can see the amount that is what do you call it? The maximum amount of solar production for the area. And we see that it will not be economically valuable to install all that solar production because of the regulatory limits. We set boundaries on how much it's possible to export. And also there are now very strict rules on how you can share in a neighborhood, but that is subject to change. So we haven't decided yet on how much we're actually going to install, but this is how much it will be possible to install, and then we will have to look on the regulatory things when we get closer to actually building the houses. Yeah. And this is like a very normal curve. You have obviously seen this before. It's the same for most areas where there is an opportunity to produce a lot more solar power than what is actually needed. So then you get the question of, is it possible or is it economically viable to install batteries, or how can we distribute the production in the area? And we've made a lot of analysis and asked a lot of questions. I'm not going to go into it, and if anyone wants to read the report, let me know. But today's presentation, I will go more into the excess heat problems. So, in regards to excess heat and using the heat from the transformer, we've looked into projects from BKK Net, which actually had two similar projects, and also Fortum and Danish Central Heating, Siemens, and EKB in Austria. And what we found is that most projects was initiated because the grid owner needed the heating for themselves. So the people who own the transformer, they needed the heat. And that's why the projects was initiated. And none of the projects was built for pure commercial purposes. So that's interesting in itself. And what we always saw, and which was kind of an eye-opener for us, is that the well-being of the transformer is always the main purpose and needs to be the main purpose. Earlier in BKK Nets, one of the stations, they had the transformer at higher. It was too hot, and actually it destroyed some of the transformer because it was the maximum amount of excess heat was the focus. And now we see that it's very important that the well-being of the transformer is the main purpose, and you can take out the heat that is produced when you run the transformer optimal, but you can't do it the other way around, because that's way too expensive to change the transformer earlier than what you could have done. And in regards to using excess heat in Norway, Eviny has been very strict that it's important that if there are any excess or extra costs in order to enable the enabling someone to use the excess heat, it's very important that the monopoly does not have to cover those extra costs. And then we also found, and that was very new to me, that the cooling system of the transformer is actually key to accessing the excess heat. And in order to get a lot of excess heat out, it actually needs to be a transformer that is designed for exactly that. Otherwise, it will be very inefficient transferring the heat. So we've learned a lot, and this is just a view of the analysis of how much energy or heat that is actually available. And what we also learned that you need to subtract both no load losses and load losses, which is variable, and naturally how much heat is available depends on the calculated load on the transformer, which is also based on the net BKK Net, what they expect the transformer to run with in the future. But there's a lot of assumptions. But we saw that 500 500,000 kilowatt hours is available from the transformer. So that's a lot and interesting. And then we looked at different options for the energy in the area, and one option would be to just use district heating, fjernvarme, and not using the heating from the transformer at all. That's the same case for an electric heat pump, which is also an option. And then there are a few different options where you use the excess heat from the transformer combined with heat pumps. And then there's a third option where you use the excess heat combined with the district heating. And when we look at the different options, it's quite hard to define what is the best option, because what is most important? Is it the investment cost? Is it the long-term cost? Is it the price per kilowatt hour during 60 years? Is it the CO2 emissions from the different solutions? And in order to complicate it even more, the CO2 emissions depend on how you calculate that. And there are 3 different ways to calculate it just in Norway. So it's a combination of very many factors, and in the end, we recommended to go for the option number 3, where we use the district heating to cover around 70% of the energy in the area, and the excess heat from the transformer to cover the remaining 30%. So this is drawing of the solution that we opted for regarding the transformer. And here you can see that you have oil and water close to each other. So to explain it for dummies like me, you have a hot oil which is close to water, and you use the hot oil to heat the water, which is then preheated, and then you would use the district heating to take it the rest up to 60-70 degrees, which is needed in order to avoid the bacteria in the water. So this solution is the robust technical solution and utilizing both the excess heat and district heating. And the biggest uncertainty connected to this solution is actually regarding the ownership, because the BKK Net, the grid owner, they can't own it, and Eviny Thermo, which owns the district heating, they actually don't need the district. They don't need the excess heat because they have enough warm water already. So that is actually something that surprised us a bit, that if a solution like this needs to be realized, then it's more the business model problematics than it's actually the technical solution. Yeah, so I think I still have 1 minute, and there was probably more I could have said concerning this, but if anyone wants to look into utilizing excess heat, I think my biggest takeaway is that the cooling system needs to be designed in order to utilize excess heat from the beginning before you build the transformer, and you need to think of the business model, who owns what and who pays whom, before you do it, because that's it's always it's what's shown us that it's always where problems appears. Thank you.